Hi, you've clicked onto today's tropical tidbit for Tuesday. We've got a trailing front down here in the Gulf of Mexico and off the South Atlantic coast. This is developing a low that's going to head up into New England. Not a problem tropically, but it could be nasty weather for them up there. This part of the front, the tail over here, should be watched warily in the western Gulf over the next couple of days, really the rest of this week, as some upper ridging may try to build over the Gulf of Mexico, and this could be a little bit of a rain event impacting the Texas Gulf Coast Thursday onward through the end of the week. So just keep an eye on this. I don't think anything too awfully serious will come of this, but we've seen examples so far this year where we've had a couple tropical depressions, almost a third, develop off fronts in the Gulf of Mexico. So we've learned our lesson that these have to be watched. So just keep an eye on this feature for the rest of this week. This is Hurricane Danielle over here in the Central Atlantic, and the funny thing is, she's not even a hurricane anymore. This is at best a strong tropical storm. She really fell apart overnight. The Hurricane Center was generous and gave her a Cat 1 at the 11 a.m. advisory, but if we zoom in, we'll see what the problem is over here. You notice right off the bat, you can see the surface center, and when you can see the surface center, that means the storm is not a hurricane, because the CDO is gone over here. And we noticed that as soon as the CDO disappeared, the surface center started outrunning the rest of herself. That's called speed shear, when the low-level flow is stronger than the mid-level steering flow. And as soon as the CDO was gone, it can't hold on to itself, so now the upper high is displaced a little bit to the east of the center, and this is starting to run off here. You can see a fractured convective band to the west. And this is a really sad-looking storm, to be honest, this morning. And what happened is we had a bunch of dry air ingested into the system. If you look at the microwave total precipitable water imagery, you can see this big breath of dry air that she just inhaled right into her circulation last night when she wound up, and this has really caused a lot of the convection to collapse. And the problem over here is we've got the big Bermuda high sitting over here south of Bermuda, and remember that on the east and southeast sides of the high, the airflow is confluent, meaning that air is piling up in the mid to upper levels, inducing sinking, and that causes it to warm and dry, and you get dry air with a fairly cloudless region over here on this side of the high. But over on the west side of the high, you get a diffluent flow aloft, which means spreading out of air, which initiates rising to replace the air that's spreading out. So you get these clouds over here. So you notice the clouds on this side of the high, nothing on this side of the high. And this is exactly why you like to have a tut in the Central Atlantic. We always usually think of the tut as a limiting factor, but really it's nice to have it sitting here. Why? Because it ventilates the Central and Eastern Atlantic where Cape Verde storms try to develop. And then once they get going, if Danielle was developing as a solid Cat 2 today, imagine the tut sitting here, it would bust the thing. The tut can't really shear a major hurricane if it's really pumping, and the tut isn't too awful strong, it'll bust right through it. So it's not a problem in major seasons. But if you have a high in here, if you have a hurricane running right for an upper high from the east or southeast, you have it running right into a confluent area aloft and right into this dry air. You notice that there's no outflow on this side of the system. All the outflow is found on the east side. Nice looking outflow there, but nothing over here because the air is flowing this way and converging and sinking, so it's running right into a very unfavorable area. And this is why I thought strengthening with Danielle would be gradual over the next couple of days. I didn't think she would fall apart like this in one night, but I did think this would limit her intensity. The idea was that once she got over here and this trough started digging in to pick her up, weakens the high, and she gets up in here, that she could get ventilated enough by this before the trough started shearing her for her to really try to wind up into a major hurricane by the time she got to the latitude of Bermuda. This knockdown right here is a setback that may lower her chances of becoming a major hurricane, but I do think she can come back from this eventually once she mixes this out. But this is why you don't want a hurricane approaching a high perpendicularly from the east or southeast in the tropics, because it's running right into the confluent zone. And hurricanes don't like downward motion. They don't like sinking air. They don't like dry air. And we've learned that lesson over and over again. And Danielle's messing with a bunch of it today. So we'll see how she does for the rest of the day. See if she can make any kind of a comeback. But this is no longer a hurricane. Alright, this is the model tracks, Hurricane Center, and models mostly unanimously taking this out. Interesting to see some of these ensemble runs showing up yet again over here. I'm pretty much thinking that the US East Coast can rest easy with this, but Bermuda over here should still watch this, especially if it's weaker. Could take more of a westerly track before curving out. So keep an eye on this, Bermuda, and see if it can pass close enough. Even if it passes by to the east over here, you can still get some gusty north winds on this side of the system, because this could become a large hurricane, as they tend to do when they recurve out in the middle of the ocean like this. So Bermuda, keep an eye on this, but probably a recurving storm. And this over here, forgot to show you, is Invest 96L. Should be Earl eventually over here over the next couple of days. Following Danielle, we'll have to watch to see if it follows her right on out, or if she tries to, or if Earl tries to get trapped and then come back west, perhaps more towards the U.S. coast. But we'll see how that goes. A long way off yet still, so we'll be watching that. And finally, again, as Danielle recurves out, we may want to watch for homegrown mischief again off the southeast U.S. coast or in the Gulf of Mexico. This is the Canadians Look at Things. This is Danielle heading out over here, and it's kind of hard to see these dashed lines over here, but these are thickness lines which give a rough idea of the 500 millibar pattern, so try to see these dashed lines if you can. We notice Danielle's leaving, trough recurving are out, and a loose trough left behind over here with the ridge building in over southeast Canada. This is day 7. We go to day 8. We notice the trailing trough left behind. Her recurving trough is leaving a piece behind. Big ridge building into southeast Canada, and we start thinking to ourselves that we got big ridge, little trough piece left behind. Start watching down here, and we see lowering pressures, area low pressure southeast of the Bahamas. We go out to day 9, and we got the trough is gone. We got a big ridge building into the southeast Canada and northeast U.S. We think we should be watching underneath, and there we go. Low pressure sitting down here east of the Bahamas underneath of the big high, and this is a classic trough split pattern for homebrew mischief that we should be watching. So we'll see how this turns out over here, see if we do get lowering pressures either in here or back in the Gulf. Either region could be a possible candidate for mischief, so we will be keeping an eye out for that. And Earl and any other friends that may pop up in the tropical Atlantic this week and next week. Alright, that's it for today. Thanks for watching.